In this video, we will be discussing Stackelberg Competition and how profits change when a firm makes the first move. Here we have a problem where two firms are deciding whether they should enter a new market, but due to time and resources, the firms enter the market at different times, and they ask us to determine the profit for each market depending on who moves first. And we're given a price function of P equals 350 minus 15Q, a marginal cost for firm A of 25 plus 3QA, a marginal cost for firm B equals 14 plus QB, and we're given that firm B moves first. So with Stackelberg, two firms enter the market to have oligopoly competition, but one firm enters first. So as a result, the firm that enters the market first enjoys monopoly competition for a little bit before the market changes to an oligopoly. And this can have effects on the profit for each firm. So one thing to note is that our price function has a Q, and we know that Q equals QA plus QB because Q is total market quantity and takes into account both QA and QB. So we can rewrite our price function to equal P equals 350 minus 15 times QA plus QB. And if we distribute that negative 15, we get P equals 350 minus 15 QA minus 15 QB. Now the first major thing we want to do is we want to profit maximize using the profit maximization rule of marginal revenue equals marginal cost for the firm that moves second. So in this case, we would use marginal revenue of A equals marginal cost of A. And we would use this to get a reaction function. So first up, we would find our total revenue of A in order to find our marginal revenue of A. And total revenue is price times quantity, and that equals quantity of A times 350 minus 15 QA minus 15 QB. And if we distribute that QA, we get a total revenue of A equals 350 QA minus 15 QA squared minus 15 QB QA. Next, we want to find the marginal revenue of A. And marginal revenue is found by taking the derivative of the total revenue function with respect to Q, in this case QA. And we get 350 minus 30 QA minus 15 QB. So we now have marginal revenue of A, and we were given marginal cost of A at the beginning of this problem, so we would profit maximize using marginal revenue of A equals marginal cost of A, and we have the marginal revenue, which is 350 minus 30 QA minus 15 QB, and that equals our marginal cost of A of 25 plus 3QA. And what we want to do is we want to solve for QA in order to get a reaction function. So what we will do is we will add 30 QA to both sides, as well as subtract 25 from both sides. And we get 325 minus 15 QB equals 33 QA. And if we divide both sides by 33, we get 9.85 minus 0.45 QB equals QA. And this is our reaction function for QA, So depending on how much quantity firm B produces, firm A will produce a certain amount to get their maximum profit. But what exactly do we do with this reaction function? What we will do with this reaction function is we will plug it back into our price function. So we have our price function of P equals 350 minus 15 times our QA, which is 9.85 minus 0.45 times QB, and then minus 15 QB. And by distributing that negative 15, we get a price equals 350 minus 147.75 plus 6.75 QB minus 15 QB. And if we combine like terms, we get a price function of 202.25 minus 8.25 QB. So this is our price function for QB. So depending on how much quantity QB makes, this will be the price of the market, as it already takes into account QA. And from here, we can profit maximize this like a regular monopoly and find our quantity B. So first, we would need to find total revenue of B, which is price times quantity of B, and that would be quantity B times 202.25 minus 8.25 QB. And by distributing that QB, we get 202.25 times QB minus 8.25 QB squared. And then now we want to find the marginal revenue of B, and that is found by taking the derivative of the total revenue function with respect to Q. And that derivative ends up being 202.25 minus 16.5 QB. And since we were given marginal cost of B at the beginning of this problem, we can profit maximize using the rule marginal revenue B equals marginal cost of B. And we have 202.25 minus 16.5 QB equals 14 plus QB. And we want to find QB. So we will add 16.5 QB to both sides. And subtract 14 from both sides. And we get 188.25 equals 17.5 times QB. And if we divide both sides by 17.5, we get QB equals 10.76. So for whatever good firm A and firm B are producing, firm B would produce 10.76 units of whatever good they are producing. And since we now know what QB is, we can also find QA using the reaction function we found earlier. And that reaction function was QA equals 9.85 minus 0.45 times QB, which we know now is 10.76. And we find QA to equal 5.01. So firm A will produce 5.01 units of whatever good the two firms are producing. And we can see firm B produces more than double of what firm A produces because firm B made the first move. Now, since we have both quantities, we can find our price for this good. And our price function was P equals 350 minus 15 times QA plus QB. And we now know QA to be 5.01, and we know QB to equal 10.76. And if we plug this into a calculator, we find our price to equal 113.45. So for whatever good firm A and firm B are producing, they will charge $113.45. Last but not least, we want to find our profits for both firms, and our profit function is price times quantity minus total cost, and in this case they give us marginal costs, so our total cost would be marginal cost times Q, because when we're profit maximizing, our average cost is equal to our marginal cost. And average cost is just total cost divided by Q. And if we want to find our profit for firm A, we would have our price of 113.45 times our quantity of 5.01 minus the marginal cost function of 25 plus 3 times 5.01, and that is multiplied by 5.01. And we plug this into a calculator to get a profit for firm A of $367.83. Next, we want to find profit for firm B, and we can find that using the same function of profit equals price, which is the same 113.45, times our quantity of 10.76 minus our marginal cost function of 14 plus Q, which in this case is 10.76, and that is multiplied by our quantity of 10.76. And we find our profit for firm B to equal 954.3. So, as we can see, the profit for firm B is more than double the profit for firm A. So, it can be assumed that there is a first mover's advantage here, as firm B made the first move, and as a result, earned a higher profit. So, in an actual scenario, when two firms are deciding whether or not to enter a new market, they will always enter the new market as they want to make more profit, and they will always want to enter the market first, because that means they will make a higher profit than the other firms that enter at a later time. And the fact that they get to operate as a monopoly for a little bit and have complete market power. That will conclude this video on Stackelberg Competition.